Hi, my name's Andrew and I'll be presenting my turn in number 2 problems. So in my first problem I dealt with a bioreactor which is fermenting yeast to produce ethanol. And during this process energy is actually generated. So the question asks us to find the volume at which this steady state process can occur. To do this we have to consider the desired internal and external temperatures, the heat loss, which is a measure of both the conductive and convective heat transfers at play, as well as the energy generated by the yeast. So to do this, a heat transfer resistance diagram was mapped out here. And in it you can see we have the convective heat transfer of the fluid on the wall, the conductive heat transfer of the metal wall, the conductive heat transfer of the thermal jacket, as well as the convective heat transfer of the air outside. Once these resistances were found, they were summed and used to find the total heat loss of the tank. And then using an energy balance, this was equated to the energy generated by the yeast, from which we could find the volume at which the steady state process occurs. If a thermal jacket of cooling water were used, the conductive term of the thermal jacket would be replaced with a convective term, and that would likely lead to greater a greater volume in the tank, since more heat would be removed from the system. My second problem dealt with drug delivery. This is a transient mass transfer problem. In it, a pharmaceutical company is trying to determine if a new drug delivery method crosses the blood-brain barrier successfully and sufficiently for their purposes. The company needs the drug to diffuse between 15 and 50 micrograms per meter squared second due to the safety concerns of the drug. This problem was modeled at steady state over a short time period, such that the inside of the brain could be modeled using a concentration of 0, and the outside could have a concentration of 40 molar. The drug had a known molecular weight, which comes into play later, as well as coefficients of diffusivity, either using the carrier method, which is the new proposed method, and the regular normal diffusion method, which can be seen above. And so to solve this problem, first we had to consider that we were looking at steady state mass transfer. All of our we had to find all of our assumptions, including an isotropic assumption, and then constant inner and outer concentrations, which is pretty important for this problem. The length of the endothelial wall was found from scientific literature, and Fick's law of diffusion was used, from which the concentrations as well as the diffusivities were used to find the molar flux, and then this molar flux was transferred to mass flux. This was done for both the carrier method and the normal diffusion method, and it was found that the carrier method was within the range the pharmaceutical company was desiring, whereas the diffusion method was not. My third and last problem deals with a musket ball cooling through the air as it's being shot at a barrel of gunpowder in an attempt to ignite it. The musket ball's surface temperature must be 110 degrees Celsius when entering the side of the barrel after being shot in the air for 10 seconds. The musket ball we're given the convective and conductive heat transfer coefficients for this musket ball flying through the air at this speed, and we are asked to find if this ignition is possible due to the cooling effect of the air on the musket ball. We're asked to assess this problem both in using lumped analysis and 1D transient analysis, and then we're asked to compare the methods. To do this problem, we listed our properties, which were pretty important for this problem. The lumped method utilized critical length, which is R/3. This was then used to find the Biot number, which was lower than 0.1, which shows that this method is actually accurate, sufficiently accurate. Then the lumped analysis method was used. The temperature, the final temperature was found to be 131.57 degrees Celsius, which is greater than our 110 ignition temperature, so that barrel is going to blow up. Doing the same analysis with 1D analysis, 1D spatial analysis, the critical length is now changed to only the radius of the sphere, and the Biot numbers. Next, the Biot number is then found, and this is used to find our constants, our A and gamma constants, which are then used for the transient analysis. Tau is found using all from its components, and since it is greater than 0.2, this method is also considered accurate. From there, the final temperature of the bullet was found, and it was found to be greater than 110 degrees again, so that barrel is going to blow up. So comparing these methods, the musket ball method is probably preferred since it's easier to deal with and it is sufficiently accurate, so it's probably the more applicable method. However, the 1D analysis method is actually more accurate of a model since it considers the temperature variation with radius within the musket ball. Yeah, thank you.